Okay, everyone, let's start. And let me see. Let me just record the video. Hello, can everyone hear me? Okay, yeah, I probably can hear me. In case you cannot hear me or have any questions, just unmute yourself and talk because by default everyone's muted. Let me record. Uh, okay, looks like it is recording. I don't know whether it's let me see whether it's recorded in my directly here or let me see here. Give me one second. Let me just figure out. Let me figure out the what. Uh, Let me figure out the recording settings here in the Zoom. Let me see. Yeah, looks like it's recording. Okay, good. Then we can start with my lecture two. Let me open lecture two here. Okay, so in the last class, I believe we finished before the last here. First of all, one thing. So again, I hope everybody can go to this Google Drive I shared with everyone, and it's actually in the syllabus. It's all the links are here, so you can just click and to see the video recorder playlist and also this
I,
Google Drive, and then everything should be there. Okay. I
yeah,
will
I'm
actually
sorry.
to lecture two after this class because I added several about I forgot how many pages, some new pages, something about import and PYPI about Python here. And this is a list, and you can see this is our lecture on Tuesday. Everything's here, so just help everyone to review, or in case you cannot attend the class, the live class. Okay, now let's have a look here. So let me give a very quick review. Let me just turn this one off. So first of all, we introduced the Jupyter notebook, and in the Jupyter notebook, here we have those command and also the edit mode. And then we can just make different cells, and then we introduce the markdown to mark down something to let us coders to read. And then some basic things about those formats. And then we introduced first the print function, the input function, and then we introduced the numerical variable printf function, uh, then Boolean variable, uh, and then string variables. In the string variable, we introduce, for example, the index, the length, dot find method, the upper, lower, title, is upper, is upper, is lower, is title, all of these methods. And then strip method, and then we have exercise one, which is, let me see, what is that? Okay, input a name and then use the strip function and the split function, right, to make it to be in the list. Here we've already mentioned the concept of list, but in the beginning of this class, we just here now we are having a brief review, but right after it, our formula introduce what is a list, okay? And then I test it? I forgot. Let me just have a look. Wait, I see the chats. Okay, I saw there's a message saying that I don't have access to the PPT slides. You can just do you have the let me see.
Yeah, I don't
I
think
can send
I
you
don't,
the
I didn't receive an email from you, Professor.
okay, so you don't have the link. Let me give me 1 second. Let me just
Yeah, I don't have the link as well.
that's interesting. The secretary Hannah, she should have set up everything. Let me just where's the you said Google Drive, right? Okay. Let me just okay, here we go. Again, I typically don't have a look at my the other screen, which are those kind of I don't know those kind of zoom setting, because I'm using a laptop and my main screen is very small. I cannot tolerate, you can see the YouTube video. I cannot tolerate all these in my screen because otherwise I won't have enough space to see the coding area. So if you have any questions, don't be shy. Directly unmute yourself and tell me, okay? Otherwise, I worry that I'm coding, I cannot see your message and then, okay, so I just sent a message to everyone, including the link. Why the P equal to drive link is not included? I'm not sure. That's interesting because everything should be one part. You you probably need to include this P equal to drive link because otherwise it's this P. I'm not sure. Is it a passcode or something? You can try. I have it now. I believe the college shared the folder with us. Okay, great. Okay, then let me continue. Again, if you have any questions, just directly unmute yourself. Don't just write a message, okay? Because I cannot, especially if I'm coding, I won't have keep an eye on the message part there. Okay, let me continue here. So here, well, we'll have the strip split functions to make it to be to be in split them to be first and last name. I guess I'd better just Anaconda. Let me just open it. So this is first of all, I assume everybody has applied something. As a really suggestion, do not accumulate everything until let's say I just never have a look at the slides until I have the first homework and I say, oh my God, especially if you're not familiar with Python, you may say, oh my God, why so many things need to learn? It's too much. A good habit in my personal view is every time, for example, when I finish it, you have a look at the slides, go to Jupyter Notebook and just code it by yourself. Trust me, it's really simple. It's not like before, like PyCharm or like Anaconda platform, a navigator when to install and upgrade, update those kind of environment very troublesome. Now everything's online, just one platform, super simple. And I click Jupyter Notebook, and then we should wait for the server for a little bit because I do want to have a look at the exercise 2.1. Okay. Quick. Okay, good. So let me see at this about first name, last name. I don't know what is your. I think it's here. First name, last name is here. Oh, okay. A bad thing is again, you see, there are no line numbers. So I will make it command mode, Shift L, command number, line number, or you can make it, here, show line number something here. So what we do is here, remember what's your first name? So I write it this way, John Smith. Of course, I wrote it, on purpose like this way. So and then immediately it will split John and Smith. Why? Because I first use the strip to remove all the front, all the beginning and the ending blanks, and then I use the split to get dot title. Sorry, this dot title to make the John to be this format, and this Smith to be this format. And then I use the split method so that this John gonna be in the first element in the zeroth element in the list, and this Smith will be the first element in Smith. And here we go. That's nameless 0, nameless 1. Okay, here we go. And then we introduced more things, examples from Paul conversion between string and the number variables. And then we run this example, which is a Fahrenheit converting to Celsius. Of course, you can do vice versa, super simple. And here we go. Typical mistake is here. Do not forget the float. Why? Because if you just write f equal to input of this from 70, this 70 is going to be a string variable. You know what I mean? Like a string variable minus 32. Python doesn't understand, hey, what do you mean? Let's say a name minus 32. It doesn't make sense, right? So you need to use a float. So it knows, oh, okay, it's a number. It's a numerical variable. So it's 70.000 minus 32 divided by 1.8 equal to 21.111 Celsius. That's the point, okay? Again, if you have any questions, just unmute yourself and then, I will know. Okay, so, excuse me. So let's have a look at the second part. The second part of this would be, the next part, sorry, would be the list. So what's a list? List is actually a collection of a string or a number as a variable. List is ordered and changeable. It's different from something like tuple, stat, dictionary. I believe in this lecture you will touch dictionary and the tuple. But stat sometimes are also interested because you can just take it and you can use that to filter those kind of repeated elements because filter do not allow duplicate numbers. We will see it when later we apply this dictionary tuple something. They're actually very, very important, especially nowadays. If you write some codes using API, API nowadays is super, super popular, and then you probably will use dictionary because it's gonna save your life. Otherwise, if you just want to brutally just like brutally link A and B, and if you do more and more, you'll feel really, really dizzy. But with dictionary structure, it's super simple. Anyway, let's see some examples. So here, let me see here. I will have course. Let me go back here. Okay, so here I will have formal course equal to calc, and then let's say linear algebra, and of course our machine learning. Okay, so first of all, this means what I created a list called course, including 3 elements. The 0th element is calc, first element is linear algebra, and the second element is machine learning. Okay, so now I can also create, for example, a grade. Let's say, for example, 90, 80, and 100, I guess. Yes, 90, 80, 100. And I see I have another grade, which is grade 2. It's similar, but just make it to string. Be careful, grade 1 and grade 2 are different, okay? Although like from us, we see, oh, they look similar. Just all of them are just like 90, 80, 100. But from Python's view, it's different because why? These are, all the elements are string, sorry, are numerical variables, while here, all the elements are strings, okay? So it's, sorry, not the numerical variable. They're numerical and here are string. So they are very different. And then I can just, for example, remember we mentioned the function type before, right? So I can just type those things. So for example, type, let's say I can say course, type grade 1, type grade 2, and then you will see what happened. Oh, sorry. Why there's no 2? Okay, so and you can see class list, class list, class list. See it? Recall that last time what did we do from I say A equal to 1, and then I say print type A, it's gonna say integer. See, this means A is an integer variable, but here, did you see it? Class list. This tells you that this is a list, okay? Okay, so this is the first thing. The second thing, recall what we did in the index part of the string. Remember, I remember we play something for fun here. Here we go. I'm learning Python, something like that. Remember all those kind of operators from per column means what? A to B. Column A to B means A to B minus 1, okay? This is not 27, this is 26, okay? And similar things, if before or after the column, there's nothing, that means all. Let's say 3 column, that means what? From the third element to the end. Empty column 7, that means what? From the beginning to index 7. Okay, again, index begins from 0 instead of 1. And also A to B means from A to B minus 1. Okay, so here in the list, we can do exactly the same thing. Okay, so here I've already typed, I just remove it since you've already seen it. And then I can print from the course 0 to 2. And then I can print from whole course back to 1. Let's just directly have a look first. 0 to 2, 0th element, calc. First element, linear algebra. And 0 to 2 means what? From 0 and 2, 1. You know what I mean? The 2, I mean, the last element means 2 minus 1, okay? And then negative 1 means the last one. Of course, it's machine learning. And then we can do something like grade 1, grade 1, 1 plus grade 1, 2. Let's see what's gonna happen. So I'm gonna, I just commented so it won't be run. So I can grade from grade 1 plus grade 2. Yeah. And then guess what's gonna happen? So this is grade 1 list, right? So sorry, it should be grade 1 list. Grade 1, 1 is what? Is 80. Again, this is grade 1, 0, okay? zeroth element, the first element plus the second element, so it should be 180. Oh, great. Great is not here. So the answer is 180. And then what's gonna happen if I have grade 2 1 plus grade 2 2? Will it also be, let's say, 180 as a string? No, it won't. Remember what is string like addition? That means like connect them. So this will be A0100, okay? If you don't believe it's right, A0100. See it? So be very, very careful about the string versus number, your numerical variables, okay? And to tell you something interesting, it's not only like this. I can even write it this way if I want. Let's say I can write, let's say Mary, and number two, let's say 90. You see an interesting thing here, which is I think this list includes both string and number. It's fine. That's what I'm saying. List is what somewhat like a container. See it? It allows it, you can change the order, and also you can have duplicated numbers. It doesn't matter. Let's say I'm named to be Mary 9090. It doesn't matter. It will tell you Mary 99. Both are 90. It doesn't matter. So it's just like a container, and I believe list is the most commonly used structure among all these. Later we'll see actually tuple dictionary are also very important here. Okay, so any questions here? No. Okay, this is a very fundamental introduction about the grade, about list. Then let's have let's see more examples. And then now I can have multiple names equal to Mary, John, Zach. Okay, now I can have the grade here as well. I'm just lazy. Let me just copy and paste it. And okay, so here I can actually change the elements, just exactly the same as what we did for strings. I can have protocol names too. So here we can see names two currently is what is Zach 0, 1, 2. See, but I'm gonna say, hey, no, the student Zach just quit. So now a new student, Peter, for example, just enrolled. Later we will introduce the concept of class, but here let's assuming it's just a list based. So Peter, and then I can even change the name to change the grade from a grade 2 as well. Well, Zach is 100, Peter get from let's say 80, 88, okay, get 88, then I can just print names and then print, let me make a 2 lines, make it easier, print grade. So you see we just change, so the last student becomes Zach, becomes Peter, and then the score is also changed from 100 to 88. So this is the thing. Be very careful here that for a list, if you write A equals to B, it's a mapping. It's not really an independent copy. What does that mean? Let's say here A equals to 1, and then I say B equal to A. So now I, for example, print AB. You'll say, of course, so it's both 1, right? Correct. Okay, now let's have a look. A equal to 2. Now I send you do the same thing, print AB. What's gonna happen? You're gonna say, oh, it's easy because A is changed to 2. Okay, and B is still, B is already 1. So AB, now they are 1 and 2 and 1. A equals to 2, B equals to 1, right? Very simple, right? Okay, let me tell you, this concept in the list is wrong. Surprised? Let's see. Names. I actually just copy and paste. I'm just tired to just retype everything. Okay, let's suppose I actually even don't need the grade names, and then I have names two equal to names. You see, it's the same as A and B versus the version here, right? So I can just print, let's say, names two. Okay, you see everything's the same, right? No problem. Okay. Now let's have a look at this. I'm gonna change names. Let's say names two, 3 equal to Peter. So that's gonna be gone, and then Peter's coming. Okay, now I'm gonna print, let's say names. names. And then I'm gonna print names2. Names2. You will see something very interesting. We can ignore here. Actually, we can see names is changed. Well, wait a minute, wait a minute. Okay, yes, correct. Names is changed. So Mary, John, Peter. But the interesting thing is names2 is also changed. I didn't write anything. Let's say names2 to be Peter. But why names2? I mean this list, the list names2 is also changed. You see what I mean? In other words, if names is a list and I write names2, another list equal to the first list, it's gonna be what? Be something like a mapping or a mirror. It's not, it's completely different from here. Here there are variables, and if I write b equal to a, so whatever you a change, b is still the same as long as I didn't write anything to change b. It's still the same. However, here is different. If I write names2 equal to names, that means it's a mapping from names to names2. And hence, if the original list gets any changed, then the second one will be changed as well. You see what I mean here? The immediate question is, hey, what if I want to make a copy, make it like something like an independent copy, right? I don't want to just, let's say names changed. Let's say I want to have a names of 3, for example. I want it to be independent, which is if your names is changed, then my names of 3 is still the same. Yes, you can use dot copy method. You can just say, for example, names3 equal to names dot copy. And then if you change anything, it won't be, I believe I have something here. I should have the copy method here. Here, copy. But anyway, in slide number 34, I will introduce, okay? So this is something, list. This is something very different, from a variable. Be careful about this, okay? So this is something I wrote here. It's a mapping instead of an independent copy, okay? Then let's see the next part. Okay, the next part is a list for 2D, two-dimensional list. Let's say here I can create a matrix, which is matrix, which is, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a matrix. I can just print this matrix. That's going to be this. I believe in the slides I wrote in that way, but it doesn't matter. You can just write the same thing, or you don't have to really put a space here. I mean, I just leave a blank here, just to make myself, make it easy for myself to read, and hence I write in this way. You can write in this way. It really doesn't matter. You can write whatever space you want if you want. It's, or even some space here. It really doesn't matter, okay? So now I have the matrix here. Similarly, I can change the matrix, right? So for example, I can write from a matrix. Let's say, be careful, since here is 2D. So the first, let me do this. Let's say, what if I write matrix 0? Let me just comment it. I can write print matrix 0, and you will see it's gonna be a list 1, 2, 3. Be careful. The object is a list, okay? So this is a double list, or you can say two-dimensional list. In the out layer of the list, this is the first element, this is the second element, this is the third element. We can sorry, I'd better say this is the 0th element, this is the first element, and this is the second element. I can also do the same. Let's say print matrix 2, so it's gonna be 7, 8, 9. Again, be careful. The target itself is a one-dimensional list. Okay. But what if, let's say, okay, you tell me matrix 2 is this list, but I don't care. I just want to see this 8. What can I do? Simple. It's going to be in list 2 since it's a list itself. So we can have another index, which is, this is what? 0, 1, which is 1. So if you say print matrix 2, 1, it's going to give you this variable 8. See? And this is indeed a variable, okay? So that's the thing. Of course, you don't have to say, it's a 2D. You can make it as a tensor to whatever dimension you have. Yeah, I mean, if you want to make, you can have 10-dimensional matrix. I mean, you can do a tensor, whatever you want. But similar things, it will just be index, 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 something like that. You know what I mean? So here's the thing. And the truth is, when we operate something, sometimes we may need to use, later we'll introduce a library called a NumPy. And then you will have something, for example, you will have something like import. Let's say I have a matrix here, right? Import, let's say, NumPy as n. Later we'll introduce it. And then you can write, let's say, A equal to np dot array, and then matrix. So you will actually create a matrix A. You can print A, for example, and you can say, oh, the same thing. What's the difference? Why do I need to use matrix? Because NumPy is a library, and later if we define it as an array, I mean, it's going to be really a mathematical array. It's called array, actually, matrix, so that you can do those kind of mathematical operations like the multiplication of two matrices, something like that. You see what I mean? However, if you use a list, you cannot directly do it. So we need to convert it to an array. And then the problem, however, is that here is just a 3 by 3 matrix. What if I have a 3 million, let's say 3 million by 3 million? It's pretty big. In the real application, you can have some data like several gigabytes. In that case, if you brutally you just want to convert it to an array, it's pretty painful because it could be, unless you use CUDA, like GPU or something. I mean, that's another story. But assuming, I mean, I want to make my life easier, you can actually code a function by yourself later, writing just directly by the list instead of brutally converting everything, a huge data, a huge matrix list to be array. Anyway, we will see these kind of things later in this class. Okay, so here is the matrix as a list, not a formal, I mean, array matrix, just a list. This shows you an example of the 2D, two-dimensional. Oh, wait, what did I do here? Okay. Oh, sorry. Here I also introduce, so you not only you can show it, you also print it. Uh, let's say you can say matrix. Let's say this 8. I just don't like this 8. For example, I want it to be 8 8. So here's the matrix 2 1. I mean 2 2 1 are the elements 0 at out layer 0 1 2. So the second element. Inner list layer of the list is 0 1, so it's 2 1. Okay, equal to, let's say, AAA. Now I print out the matrix. You will see this 8 becomes AAA. Here we go. Okay, so that's what we're doing here. Okay, and now the second part, the next one is a length, the length method. This is actually called a function, a length function. So this tells you the length of a matrix. So for example, here I can have a name list, right? So I still have, let me just rewrite it. Let's say I can have, let's say, names equal to this, and I can print length of names, and it's a 3 indeed. 1 2 3. Be careful, I'm not talking about index, okay? I'm talking about the length. So the length of course, the length of 3, the length of not 2, okay? Length is not starting from 0, okay? Index starts from 0, okay? And similar things, I can print, for example, the length of matrix. And the length of matrix is going to be 3, okay? But if I want to do something, let's say 4 4, I just, let's say 5 5, and then for example, this is, I don't know, let's say 10 10. And now I can just, print the matrix, sorry, I can just print the matrix. And then you see the length of matrix is 3. Why? Here. But what if, so the matrix actually has 3 rows and the 4 columns. You see what I mean? Let me just make it like this way so it can be a bit more clear. So it should be like 3 rows and 1 2 3 4 4 columns, right? What if I want to know the column? Simple. You just make it from matrix 0. So this means, hey, in the inner the zeroth element, which is this list, how long? What is the length of it? And here we can see the length is 4, so it's gonna immediately show you 4. And later again in the those kind of, let's say regression or whatever those kind of the simple machine learning algorithms will see. We will use this to get the row and column number of the imported data and do some interesting things. So this is the length function. It's a very important actually. It's the same as a string. Remember it. String will also have the length. Where? I cannot find it, but I'm pretty sure it's there. Here we go. No. Let's not list. Length of the string. Here we go. Length string. They're same thing. Okay. Okay. Now the next part of the next part of the list will be dot index, and it's actually pretty similar. It returns to the index of the first element with a specific value. So for example, here if I have here I have data equal to, let's say, -3, 6, 9, 5, 10, 6. And then you can see I have two sixes. See it? And then if I write print data dot index 6, and it will tell me the index of the first 6, which is 1, tells you 1. What if I don't like it? I don't want to just see like this way. I can have a value start, and this start means the start from which index you are gonna count. For example, if I write 6, 2, that means 0, 1, 2. I'm gonna start from this 9. Okay, so I can write. Let me just add more 6, 6, whatever things, and I write 6, 2. That means I'm gonna start from 0th index, first index, second index. I'm gonna start from here and then find out the index of the first 6, which is this one. And 0, 1, 2, 3, 4, 5. So the result should be 5. So it tells you, hey, starting from the second element, the first value 6 appears at index 5. Here we go. And the next one would be, what if something is not there? Let's say I cannot find it. Let's say here I find index 100. We know that 100 is not there. Unfortunately, this function gonna tells you wrong, error. And then it won't tell, remember find before, we have the find function. The find function is just gonna return -1. Where's find? Find function here, remember? If the substring is not found, it returns -1. Unfortunately, here in index, it won't return 1, it will tell you error. So what shall we do? I mean, how can we do something like this way? Method number 1 is again use in. The in operator is gonna tell you true or false. So I can print, let's say, 100 in data, it will tell you false. False. Or if I say, let's say, 6 in data, it will tell you true. So this is method number 1. Method number 2, I can later will introduce. We can use the count method, which will count how many times this number appears, and clearly 100 doesn't appear, so that you will get 0. Okay. The next one, yeah, true. The next one is count. Similar things. We can just directly do it. We can say, for example, data dot count 6. So we have 1, 2, 3, 4, 4 times. This means 6 appears, 4 times in this data. I can do this, for example. Be careful of this. See, 0, because there's no 6. Let me just add a 6 here. Okay, let me just add to string 6. Then this will tell you too. See it? Be careful. I'd better make a different. Okay, so numerical 6 appears 1, 2, 3, 3 times, and the string 6 appears 2 times here. So you can see, okay. Now if I put, let's say 100, 0. Okay, so this is this is actually a very easy method to handle this. The next methods I'm going to introduce are append and insert. There is something to add some elements to the existing list. So for example, here I have the data equal to -3, 6, and 9, and then append means add the value in the end at the end of the list. So data dot append. Oops, append. at the end of, let's say, suppose I add a 99 here, and then I print data again, it will be -3, 999. So it will add here. You can keep adding. Let's say you can, just add again. I'm not sure whether I can just do like this one. Oh, wrong. But you can just later, if you learn loop, you can use a for loop to just keep adding. You can just continue adding. Let's say dot append. Let's say whatever you want. So it will be like this. Okay. The bad point, however, is append is got only added at the end of the list. So what if, let's say I want to add it in a specific position? Let's say here I said 97. I want to add the 97 here. So you're gonna use insert method instead of append. Append is just, easier. So insert, this is the index, and then you put a 97, for example, here, it will insert at this place. Okay. So I can do, for example, let me just still do this. Instead of append, I'm gonna do insert. Let's say 299. What's gonna happen? So this is 0, 1. So it will be -3, 6, 99, and 9. Here we go. -3, 6, 99, and 9. Can I do -1? Uh, interesting. Be careful. If you put a -1 here, it will push this 9 there. It's not the end. Okay. So if you really want to make it to the end, don't just burn your brain. Simply use append down, which is the easiest thing. You never need to worry about something. Or you can use the length function of the data, so the index -1 is going to be the number. So these are append and index to insert, append and insert to add some elements to an existing list. Any questions so far? No? Okay. These are pretty basic things, don't worry. And the next one is remove and pop. So here is insert, here is remove, right? Here is to add, here is to remove something. First of all, remove value. That means to remove the first element of, the value in the list. Again, be careful first, okay? It's the same as here, the index is the first, okay? So suppose I have this one, I have many sixes, right? Okay, I can just use this one. Data equal to this, and then suppose I'm gonna just remove something. I'm gonna say data dot remove 6, and then I print data, and then you see this one is gone. See it? -3, 9. This one is gone. And so this is the thing. How to use this? But what if I don't like it? I just want to remove, for example, all of these 6. What shall I do? First of all, you can use loop to remove all of this. Second, later we will introduce, we can use the filter function together with lambda function, and that will be very, very powerful. Anyway, we'll see this later. And now let's introduce the pop function. The pop function means remove at the specific position. You see, actually, some of the remove is similar to index, something like that. It's more powerful than the append, because append can only add the thing at the end. But remove, I mean, you just remove the first element of this, and then pop is actually similar to this insert, because you can tell at a specific position. So here, pop index will remove this index here. So for example, suppose I still have the same thing. Instead of remove, I'm gonna say pop. Let's say pop 0. Be careful, here is no longer the value. Here is the index, okay? If I write pop 0, that means the 0th element, which is -3, will be removed. Here we go. And you can see the new data list becomes this. There's no -3 anymore, see it? And of course, you don't have to, you can say, let's say I just dislike the 6. I just don't want to remove it. Okay, no problem. You can say pop 1. Why 1? Because the index is 0, 1. Here's index 1. So this one gone. You can also, let's say, make it, for example, pop -3. So this one will be gone. You will see only one -6. Only one string 6. See it? This string 6 is here, but it's gone. 1, 2, 3, 4, 5. You can say -5. So number 10 will be gone. So see, 5, and then string 6, number 6, number 6. Okay. So these are remove and the dot remove and the dot pop methods. The next one is clear and pop and copy. Clear is if you write any codes properly, clear is the thing you like the most because clear is just make everything very clean. Why? Because it's gonna be just remove everything. However, also be careful because what if it's important data, then clear, then it's game over. So let's say data equal to this, and I put clear and print data, that's gonna be an empty list. So it's gone. It's just nothing there. And the next one is copy. Remember, we actually mentioned it here about the mapping. If you make a name to name names to names, okay. A correct method is to use a copy method. So we can do it like this way. So let me just copy and paste from there. Okay, so I have this as well. I have names as this, and then names two as this. So here, I changed. I can actually have another thing, which is called, let's say, NNN. Let me make it NNN equal to names dot copy. Names dot copy. Okay. Now I change names to be that. So now I'm gonna print names two and then NNN. Print. Okay. See what happens for both. Wait, what I have here again? Here we can just remove it. All right, let's leave three. So names, it's gonna be Mary, John, Peter. Why? Because I've already changed names element two become Peter, so that is replaced with Peter. As we just mentioned, if we write names two equal to names, so where names is a list, it will be a mapping. And hence, even if I didn't say, let's say names two equal to Peter, it's gonna still be changed. So why? It's just a mapping, you know. However, if we write n equals to names.copy, you see it? N is still here. N is not changed. It's still Mary, John, Zach instead of Peter. So this is the way I can create an independent list, okay, independent of the original list. So it won't be a mapping or something. Be very, very careful about this when, you know, this is a list instead of a variable, okay? Okay, so these are the things of simple method of list. Now let's do an exercise. We have a list for students' name, Mary, John, Zach, and a corresponding list of their credits, of their grades. 90, 80, 85, find and replace student John and his grade with Jennifer. And so I'm going to replace John with Jennifer and replace the score 80 with 100. So here, of course, you can say, oh, simple, just the names one equal to Jennifer, grade one equal to 100. No, don't do that manually. Instead, what we want to do is we want to use those kind of, you know, functions to do it. Here I use the pop function and insert function. Uh, yeah, okay. You know what? You can actually you can just simply use. Let me see here. Oh, I haven't introduced the if. So okay. So index John. Okay. Anyway, we can do it. First of all, recall what is pop function. Pop function is something to remove. So the idea is that I wanna instead from manually. Why? Because suppose think about this. Suppose we have 1,000 students, you probably don't want to manually, you know, use your eyes to check, right? Of course, here we assume only one John, okay? If other Johns, then you better match with the last name and the, for example, student ID. But the principles are exactly the same. This is just like a circle, the SQL, let's say a database system that you want to find it. Of course, later if you learn SQL, it's super simple search. But here, assuming we don't know what is that, so we're gonna just search, you know, code directly manually code the search. So what you're gonna do is that first of all, you will find where John is. Again, assuming only one John. The real case you can use student number, it doesn't matter. And then how can I find where John is? We're gonna use what index function, right? Remember, index is to return to the index of the first element. Here, it doesn't matter first or not because we assume there's only one John. Okay, and then we get its index. Once we get this index, we can do what? We can do pop. and then insert, right? Actually, once you get this index, you even don't use a pop and insert. You can directly use that number equal to. Okay, I guess I'd better just directly write the code. It makes the life easier. So names equal to this. So, and sorry, I need a grade, right? What are the grade? 90, 80, 95. 90, 80, 95. So what I'm gonna do is this. So I'm gonna say index John equals to, I'm gonna use names dot index first, and then I'm gonna say, hey, John. So this will tell me actually one. For example, I can just print in that Alex John. It should show one. Okay. So now, of course, I don't have to. I just comment it, and then what? Then now I know this index. Okay, okay. I know in the example I use pop and insert. Here I'm gonna be lazy. I'm gonna directly change it to be like index this John equal equal to Jennifer, and then grade index John. Sorry, IDX index John equal to what's the score? 100, right? Yeah, 100. So now I can just print, let's say, names and then grades, and you're gonna see that's already changed. Jones replaced by Jennifer, and then the grade what was 80 is replaced by 100. Done. Uh, uh, I mean, I actually don't know why when I wrote the this slide I use pop insert. Probably just want to show you. I mean, all those kind of like methods, but actually the one I'm doing here is a way easier. I mean, I just changed it. Anyway, you can just do example by yourself. Do this by yourself. After the class, and then do whatever. As long as it's changed, then done. But it's a good training for pop and insert methods, I guess. Okay. The next one, this is probably one of the most, in my personal view, one of the most important thing, if statement. It's really too important. So if statement is, I will give a logical test, in the program. So if it's true, then do A. If it's not true, then do B. So the syntax is here, if logical statement one, column, be very careful. This column is extremely important in Python, because in other languages, I'm going to use if, then bracket, the big bracket, but here it's just, Python actually uses the column and indentation to differentiate different layers. And then if this is true, then I'm going to do action one. Else means else if. Else if logical state number two, if this is correct, do number two. Else number logical statement number n, and then if this is correct, go to action number n. If none of these n statements are true, I'm going to do else. First of all, exactly one of these actions one plus from actions one, actions two to till actions n plus one, exactly one of them. Be careful, exactly one of them will be done. What does it mean? This means, say, suppose your logical statement one and two are not like exclusive. As long as logical statement one is true, it will directly do action one and done. It will ignore all these, logical statement two, logical statement n till else. It will ignore. You see what I mean? So it will, execute the code, with the order statement one first, two. As long as one of them is correct, it will immediately do the corresponding action and then quit the whole if block. Okay. So let's just do an example, make it life easier. Let's say here, sorry, here I'd better add something before above it. I'd better make it as a mark. Now I can just say exercise. What's the number of the exercise? 2.3 to make it more constant. Oh, I forgot 2.3. 2-3. Okay. And this is a new thing, which is if statement. I can write, for example, let's say a equal to 3. I can write, for example, if a is greater than 2, let's say print, let's say greater than 2. L if a greater than 1. I know something is very weird here, but I just want to show you this example of greater than 1. Else, print, let's say NA. NA, okay. What's going to happen here? You can see that 3 is both greater than 2 and 1, right? However, it will only do this. Greater than 1. It won't print greater than 2. It won't print greater than 1 at all. You're gonna say, hey, why? It's weird, right? Because this is correct. This is also correct. But why it only executes this line instead of line number 5? Why? Again, because it will just do exactly 1 actions. So it will do this. Let me just Python, not Python, Zoom. This is the order. So as long as I see logical statement 1 is correct, I will immediately do action number 1, actions, because it can be many actions. Number 1, it will ignore all other logical statements and all other actions. Who cares you are correct or not? Because again, exactly 1 actions. Okay, so this is the thing. Let's see some examples here. So I'm gonna ask you to input your grade, and if your grade is greater than 60, you passed, or otherwise, sorry, you fail. This is actually okay. Grade equal to, be careful, don't forget this float, because without a float it will be wrong. But let's see, suppose I don't know. Input your grade, and then I'm gonna say if grade is greater than or equal to 60, then you see in Jupyter Notebook it will automatically show the indent for me. But sometimes if something's wrong, you can always use table and the shift table to control the indent. Okay, it's different from, for example, C, Java, something. I have this, I can say blah blah whatever I do. Right here, if you write it like this, it will absolute. Actually, I don't know. Jupyter Notebook can recognize, let's say, Java or some language. Probably not. I'm curious. Let's say print, let's say A. Yeah, or probably, or let's say use /GE. No, it's wrong. So yeah, only Python. So you do need a column, and you do need the indent here. Python actually use the indentations to determine the different layers or levels of the code. Print, you pass the exam, and then else, print, sorry, you fail. Let's make it a to be comma instead of introduction. Okay, so what is your score? First of all, this will be wrong. Why? Because I don't have float. Because in this case, grade will be a string. A string, you cannot determine whether a string is greater than or equal to 60, right? Suppose I have 66. I bet you it will be wrong. Okay, how to change it in float? Just add a float here, then done. Let's say 66. Oh, great, you pass. And then what if I'm only 6? The grade is only 6. Sorry, fail. Okay, so this is the if then or if else, a super simple thing. Second thing is that I want to make it a bit more difficult. I want to make it a system, which is A, B, C, D, F. Fail is here. So I have the code here. Actually, you will see this code is can be really improved. But let's pretend that I don't know. Let me just run this code. I'm actually lazy. I can simply just do it from here. So first of all, input this one, and then I'm gonna say if the grade is less than or equal to or equal to 90, greater than or equal to 90, but less than or equal to 100. So you can say, oh, great, you get an A. You got an A. Okay, then I'm not gonna write else. I'm gonna write else if the grade is greater than or equal to 80, greater than or equal to 80 and less than 90. Print, you got B. Actually, I can just copy and paste. C, D. See here, the indentation is wrong, so I put the shift table and sorry, here, shift table. That will be back. Okay, 70. So it's gonna be 70, 60, and this will be 80 and the 70. Sorry, 70 here, and then a B, a C, a D, else, sorry, you fail. Then I remember. Okay. I have one more layer, which is invalid. Let's say, what if I print something, let's say negative 66, something like this kind of, or 111, this kind of numbers. So I'd better have another else if, and then else if is, grade as less than 60, then it's going to be, sorry, you fail. And then here will be something like invalid score, invalid grade input. Okay, so now we can just do it. And then what is your grade? Let's say 99. Okay, you got an A. And then what is your score? Let's say 59. Sorry, you fail. And then similar thing, whatever number, let's say 77, you should get a C. And then for example, what if I write 111, invalid input? Okay, here is the thing. But have a look at this code. Is there something I can actually change? The truth is that this code can be really improved. I don't have to write it this way. For example, have a look here. I can remove this. I can write, for example, grade is greater than or equal to 80. Why? So a concern is, hey, if I write it this way, what if, let's say, I get, for example, 95, right? If because 95 is also greater than or equal to 80, right? I mean, will I get a B? No, you won't. You know why? Because here, remember, again, exactly one will be executed. Because in the first if statement, you've already stated that if the grade is between 90 and 100, you will get an A. So if you really get a 95, here we go. It will directly just execute this line 3 and then done. It will quit the whole if block. Let me, can I zoom? I need to zoom. Okay, here we go. Here, the whole thing is if block. It suppose my score is really 95. So it will just do print, you got an A, and then done, quit the whole thing. Who cares what are, behind, what are, just like in the, below me, those kind of, everything will be ignored. You see what I mean? In other words, clear all, okay. In other words, I can just simply change everything to be like this way. Of course, here I'm not using switch. If you are familiar with coding, you will see there's something called switch, so I can just based on grade and a case. But here, assuming I don't know what is that, 60. Else if grade is less than 60. Be careful, here you do need it because otherwise it can be invalid, okay? Then I claim this is gonna be the same result, let's say 66, it's a D. And then let's say we said 95, it's an A. Several things, 111 should be in the, wait a minute, wait a minute. Okay, here we go. Great. That is an issue. That is an issue. It's greater than 80. True. Well, looks like what I just said was wrong. True, because if that case, if your score is one on 100, then it will still be like this way. Okay, then never mind. If that case, then for this specific example, true, we'd better keep all this because otherwise it could really be something wrong. But the logic here, the point here that I want to mention, invalid grade that I want to mention again is that for in the whole if block, exactly one of them will be executed. And hence, if you can read logic, if the logic, the logic here already is partially covered by the logic here and filtered out, I should say, then you don't need to write the other part. Okay. So okay, this is the thing for this example. We should have more examples because if it's really too important. And another thing is that in the if statement, all these logical statements here in Python, it's just gonna judge whether it's true or false. It's not like in many other languages, it's 0 or 1. 1 means true, 0 means false. But here in Python, it's true or false. And hence, we can write something like this. I can just make it to be a Boolean variable, and then directly use this Boolean variable in the if statement. Let's say if grade is grade, let's say 60 plus equals to true. Again, be careful, don't write this, okay? You can see If I write this, it is TRUE. So Python will consider it as a the small TRUE as a variable. We must write it to the capital T in an RUE. Then Python itself reserves this thing. So you cannot define a variable called big T RUE true. No, we cannot. So this shows it's a Boolean variable, and then I can say if is this one, then print. Let's say you pass. Else print. Let's say you fail. Third order, let's say you pass, because it's directly a Boolean true. You see what I mean? You can even write it this way, if true. Write this. Else this. You can even write this way, because I write if true here. So it's always why? Because true equal to true. So again, what if statement is gonna do is it will see whether this logical expression is true or not. Because here you already brutally force it to be true. So of course true is true. That's the thing. So of course you can write it this way, if false. That's always you fail. So this is the thing. In the next one, we have more examples for if statement, but here we're using those comparison operators: equal, not equal, greater than, less than, greater than or equal to, less than or equal to. Actually, we have already seen it here, but it's just simple things. A typical mistake, especially for beginners, is this. People always write equal instead of equal, because equal means it's an operator to set up a value, but equal, it's a comparison or logical operator here. Okay, so for example, I can write, let me see, what do I have here? I can write, for example, a equal to 1, and then and then I can write, for example, if a equal, let's say if I write like a equal to 1, okay? Print, let's say a equal to 1, and it will show you error. Why? Because oh my God, it's so smart actually. Typically, it will just tell you here invalid in syntax. Before I didn't show this one because it's really a very typical mistake. Okay, sure. I will make it like this way, and then it will. A very, very good example, but indeed, I made a mistake. It's not on purpose. Okay, see the point? Expected and indented block. So if I write it this way, Python will consider this Python will consider this if statement is an empty thing. Nothing's here. You see what I mean? I must have this one, print, indent. So Python will understand that this whole thing, zoom, give me a block here. This is the whole if block. Okay, so I must have the indent here. Okay, now if I do like this way, let me go back to this. Okay, then it will print a equal to 1. Or if I write a equal to 2, then it will do nothing. So this is the thing. So this is equal, the comparison operators, and another thing is called not equal. I know many different languages may have interjection equal, or sometimes they can have this equal. Sorry, they can have this equal, something like that. But here we're using interjection equal. Okay, so I can have a equal to 1. If a is not equal to 2, let's say, print a is not equal to 2. So a is not equal to 2, okay? And then, of course, we can have something like greater than, less than, greater than or equal to, less than or equal to. Let me just make one. Let's say a is greater than or equal to 2. I just print, let's say, whatever. I didn't do anything because a is indeed not greater than or equal to 2. But if I say a is less than or equal to 2, then it will print . And because a equals to 1, that's indeed less than or equal to 2. Okay, so these are the comparison operators. We will use these comparison operators a lot later in this class. And the next one is the logical operator and or not. So and means, for example, I have two statements, statement 1 and a statement 2. So I can use if statement 1 and statement 2. And logical and means this is true. Let me write it this way. Let me make a markdown. So and let's say A and B. This means this is true if and only if both A and B are true. I'd better give it a. Uh-oh, why? Uh, this should be bold. I'm not sure why this is not bold. Oh, sorry, my fault. I forgot. I need to go back for the cheating for myself. In the markdown, which one is bold? I remember the star is bold. Where's my cheating sheet? My cheating sheet is here. Okay. Ah, double. Okay, so let me go back to the Jupyter notebook. Where's my notebook? Okay, double A. There we go. A and B, this is true if and only if both are true. And then what else we said here? And or not. Okay. A or B. This is true as long or let's say if A is true or B is true. In other words, as long as one of them is true, the whole statement is true. The entire statement is true. So this is let me just add another. And a not is the opposite. Let's say not A. So A is true if this statement, I should say, yeah, this statement, let me make statement, and then here, this statement is true if A is false. And vice versa, this statement is false if A is true. So here we go. Okay, these are the logic of the operators and, or, and not. Okay, now let's have a look at the example here. Let's say I have A equal to 1. Oh, I see the chat again. So uh, uh, sorry, I just saw this one. I didn't get request access. It was one hour ago. Sorry, I didn't have to look at the message. What access? Do you mean the access of the Google Drive? I mean, the links are here. You can just click it. I believe Hannah, I mean, the secretary should open it for everyone. I guess. So let me just go back to see the share. It's restricted. Sorry, I will write it in this way. Anyway, anyone with the link. Sorry about it. Okay, so now let's go back. Again, if you have any questions, please unmute yourself and direct it talk because otherwise, I cannot code and meanwhile keeping an eye on the other screen. Okay. Okay, so here, let me have a look here. I will have. Where's my Jupyter notebook? So I will have A equal to 1, B equal to, let's say, -1, I believe I put. And then I can say and first. I say if A is greater than or equal to 1, or equal to 0, and B is also greater than or equal to 0, then I'm going to print, let's say, print what? Let's say both are non-negative. Both non-negative. Else, print, let's say, at least one negative. So of course, at least one negative. Why? Because B is less than or equal to B equals to -2. Of course, if I change B to B2, then true, both non-negative. See, again, and means both this statement one and both statement 1 and statement 2 are true, then the whole if statement will be true. Okay. So now the second example will be or. Similar things, a greater than 0 or b. Let me change it to. It doesn't matter. Or b greater than or equal to 0. No, here I need to change. It's gonna be at least one non-negative, else is both negative. So indeed, you can see this is or. That means as long as one of them are true, clearly A is true because A is, B is false. But even if that case, the whole statement, the whole if statement is still true. And hence, line 4 will be executed. It tells you that at least one is non-negative. Okay. Similar things if I make it like this way, then because both statement 1 and statement 2 are false now, because both of them are negative, so of course it will execute line number 6. The last one will be not. So A equal to -1. If not, A equal to -1, and then I'm gonna say if not A is greater than or equal to 0, then what's gonna say? If not greater than or equal to 0, that means A is negative, right? A is negative. Otherwise, A is non-negative because A will be greater than or equal to 0. So not is the reverse, okay? But the key is here, the logic. This is actually pretty simple. Okay, then let's go to the next one, which is the member operators. Actually, we have seen a lot, which is in and not in. Again, pay attention. If I use a logic like this, it's gonna be a Boolean result. In other words, it will be true or false. The result will be. Okay, so I have the pets and the fish. Okay, I see. So now I will have pets equal to, let's say cat. I must use cat, dog, and the fish. And the fish. Okay, now I'm gonna say if cat in pets, then I print, let's say cat, cat is a pet, else print cat is not a pet. So of course I will say cat is a pet. You see what I mean? And similar things you can actually print. Cat in pets. It will tell you true. And then I can say, for example, if cat, be careful, it's case sensitive. If I say the capital CAT, that's going to be false. See it false. Okay. So that's the thing. And then, here I use, sorry, actually I use bird. It doesn't matter. Nothing. Okay, I'd better just make it the same bird. Make it the same as the size. And I can write it, if not, what did I write here? If not, if fish not in, sorry, fish not in pets, then I'm gonna say fish is not a pet. Fish is not a pet. So, and here, indeed, you can see cat is a pet, fish, I forgot H. Fish is not a pet, okay? So here's in and not in. And then similar things, you can just print, let's say, fish not in pet. It will be true because indeed, I mean, fish is not in pet. However, if I say cat not in pets, which is false because cat is indeed an element of pets. So here we go. So this is in, not in. Okay. Okay. After learning all of these, let's start exercise 2.4, which is okay. Suppose the standard tuition, it's the tuition calculation, and trust me, this occurs indeed in most universities. Suppose the standard tuition per credit is 1,000. I don't know how much now. I guess it's much more than 1,000 nowadays. And the tuition can be waived if a student's overall GPA is greater than or equal to 3.9. I'm not sure. Does your university have this policy? I would love it. This will really encourage students to get high GPA, isn't it? In addition, a student can get a 5% tuition reduction if the GPA is greater than or equal to 3.5, 10% reduction if the student is a veteran, or 15% tuition reduction if the student is an Alabama resident. Here, because it's a class for U of South Alabama, so it's Alabama resident. For different states will be different, requirements. And oh, sorry, pay attention that a student could satisfy multiple conditions and get the corresponding discount simultaneously. Suppose my GPA is 3.5 and I'm a veteran and I'm an Alabama resident, so I can have all of them, and hence it will be 0.95 times 0.9 times 0.85. So if I satisfy all of these conditions, my credit, my tuition per credit will be this times 1,000. It will be 726 and 75. So I need to write a code, and I want you to input a student's GPA and then ask whether or not you're a veteran, and also whether or not you're an Alabama resident, and then finally output will be the final tuition for the student. What can we do? Okay, so we can write it in this way. It's going to be what exercise 2.4. Okay, so now we can do what? First of all, I will need the user to input the GPA, right? So I'm going to say GPA equal to float. Don't forget, otherwise you cannot compare. Input, what is your GPA? And then I'm going to say is veteran equals to input. Are you a veteran? And it will be yes or no. And the third is AL resident. Are you a resident of Alabama? Sorry, Alabama. And also similar thing, yes or no. Okay. Now I will have what? My initial tuition is what? Is 1,000. Okay, now I can start coding. So if the GPA is greater than or equal to 3.9, it's a free. Otherwise, 5%, 10%, 15% if the GPA is this and is a veteran and also AL Alabama resident. Okay, so I can have if GPA is greater than or equal to 3.9, then what? Tuition equal to 0. So I'm done here. I actually don't need to even judge any further. People may say, hey, if your GPA is greater than or equal to 3.9, what if, let's say, I'm also a veteran or I'm also an Alabama resident? It doesn't matter. Why? Because their tuition is already 0. You see what I mean? So here in this if level, I just need to see whether it is greater than or equal to 3.9. Done. If it's a 3.9, 0, I don't care actually whether you're greater than or equal to 3.5 or you're a veteran or Alabama because it's already 0. So I can have the else here. Now here under else, I will have another if block to detect whether your GPA is greater than or equal to 3.5, because else means my GPA is already less than 3.9. Then I'm gonna ask you, hey, is your GPA greater than or equal to 3.5? If yes, then what's gonna happen? Tuition equal to tuition. So I can use multiple equal. This means tuition equal to tuition times 5%, right? 0.95. So because I'm lazy, I don't have to write tuition again, so I just write multiple equal 95. That's it. And then I can say what? Can I use else if? LF, let's say, is veteran equal to true. Is this correct? There are actually two mistakes here. Mistake number one, you cannot write equal. You must write equal. Why? Remember here, the comparison operator in what? It's equal. Sorry, give me 1 second. Yeah. Sorry, my cat is in the room. Just kick it out. Okay, so here in the if statement, it's comparison. So you need to write equal. Second, this LF here is not correct. You know why? Because we specifically mentioned here, where it is. We specifically mentioned here that a student can satisfy multiple conditions. If I write LF, remember, in the whole if block, exactly one actions will be executed. Then if logical statement one, which is if my GPA is greater than 3.5, then it will directly only execute this one. You see what I mean? In other words, if I'm also, let's say, a veteran, this discount won't be calculated. Very simple. Let's just try it. Let's say is veteran, then I'm gonna say tuition time equal to how many percentage? I forgot again. 10%, right? Yeah, 10%. 0.9. And then let me just use LF, okay? You will see why this is wrong. Is AL resident equal to true, then tuition time equals to 0.85 because 15% discount. Here, be careful of my indent. Now I'm already out of the hole, so here I have two if blocks. This is one if block. Then let me use another color. Zoom, give me another color. Okay, this is the second if block. See it? But now I'm already out of this if block, so I'm gonna say print tuition. And you will see this will be very wrong if my GPA is really higher than 3.5. Let me just run this code. What is your GPA? First of all, let's verify if it's more than 3.9, greater than or equal to 3.9, so it will be free. Are you veteran? Actually, it doesn't matter. Let's say yes. Yes, it doesn't matter because it's going to be 0. Okay, now suppose my GPA is 3.6. As we suppose my GPA is 3.6 and I am a veteran and I am an Alabama resident, as we just calculated, we should get this result, right? But you will see the result will be 950. Let's say yes, yes, 950. You see why this is wrong? Because, let me clear all. Because use LF. Again, in this whole structure, exactly one will be executed. So once Python C, here my input is 3.6. Okay, I'm gonna do this step, which is tuition equal to 0.9. Done. I will just ignore all of the, I will just, I will just give me another color. Give me 1 second. I will ignore all this. You see what I mean? And hence here, you cannot write LF. Instead, you should write if. Because, all of the, I can satisfy all of them. So here, if this is satisfied, the tuition gonna be from what is here 1,000 to 950. And then if this is also correct, then it will be 950 times 0.9. Then if this is also correct, then it will be the number times 0.85. Okay, now let's run it. 3.6. Yes, yes. Huh? Wait, why? Give me 1 second. Wait. Sorry. My fault. It's not why. It's not true. It should be why. My fault. Then I probably need this. Sorry. I probably need this. Dot upper. Yeah, because I could put a small y. Sorry, it's not true. Give me 1 second. Let me just upper. This is also y. First of all, let me show you the error thing. So again, let's go back to the LF 3.6. I can't put a small y, doesn't matter. So first of all, this is wrong because it ignores this LF or LF. Exact one will be executed. Now let me correct it to if. Then it should be correct. Here we go. String no upper. Okay, great. I put a 3. 3.6. Y. Okay, here we go. See it? 726.75. Because these three conditions are parallel. They're not like under the same if block. So here we go. Okay, so yeah, that is the of course you can use the final, your final tuition as whatever provided. I mean, it's pretty beautiful, but it doesn't matter. Your your final tuition is tuition per credit, then 3.65 for example, yes, and then for example, no. Then it will be like 8.55 per credit because I only get discount of this one and the discount of this one. So 0.95 times 0.5 is 0.855 and times 1,000 is $855 per credit. Well, I wish nowadays the tuition is really so cheap. I saw some crazy things like almost 3,000 per credit. I forgot which university. There's a university here in Colorado Springs. I was just shocked. Anyway, any questions here about if statement here? No? Okay. The next one is another. So in my personal view, if in any coding language, not necessarily Python, if statement and the loop structure, these two things are the most important things. As long as you know this, all other things are just different syntax. Like you can code the Java, JavaScript, C, C++, Python, whatever you want. But the idea is, the most, in my personal view, the most important things of all the structures in coding is actually if and a loop. Okay, so first of all, what is a loop in case you've never coded before? So loop structure actually provides a way to repeatedly execute a block of code. So for example, suppose, I have let's say list one equal to suppose here's my human language. Of course, it's wrong. Let's say 1, 2, 3, 1, 2, 3. Let's say 10,000. I want to create a list like this way. How would you create it? You say, oh, okay, it's easy. I just write. The problem is that you need to write 10,000 times. I mean, it's gonna really kind of like kill me if I write it this way. But if I can use a loop, I can easily just create such a list. I believe here in my examples here is okay. Suppose I've already had such a list, let's say from 1 to 10,000. And then now I'm gonna update this list. I'm gonna say, hey, I want each number add 1. So what would you do? You want to change it manually. It's gonna kill you. You need to manually update it for 10,000 times. So loop structure is something to repeatedly execute something like this. So we want to have numbers, 0 index plus equal to 1 and numbers 1 plus equal to 1. I can just use a for or while loop structure to just 3 lines and I can finish it. 2 lines actually. Here, I don't need to write and for and a while something, just 2 lines, I can finish it. So that's a meaning. In other words, I want something to be repeatedly executed. So this is the loop things. And here I wrote combinations of the combination of loop and if statement. They are actually the foundation of all. I actually want to remove most and replace it for all programming all programming languages actually. Okay, here let's have a look. We have two common types of loop. First is called while. Second is called for. For is just this for. Okay, so first of all, let's have a look at while. The syntax is here. While logical statement, then if the logical statement is true, I will do actions 1, and then go back to logical statement again. If it's still true, again, still do action 1, repeat until the logical statement is wrong. Then I will do the thing included in else. And this else clause is optional. So if I don't have else, it doesn't matter. That means the whole while block will be just complete. That's it. So here, first of all, here's the explanation. It will just evaluate the logic condition or logical statement. If it is true, then do actions 1 and then go back to test the logical statement again, and then if you're not clear, you can just read this part, okay? As a reminder, do not forget this column and do not forget the indentation here. They're really required. Okay, here we go. Let's see some examples. Uh, First of all, I better just code it. Let me just, I can have, for example, A equal to 3, B equal to 0. By the way, here I wrote it this way because they're the same meaning. If you want to write different things in different codes in one line, then you are going to use semicolon to let's say 3 point C equal to 3 to separate them, okay? Or you can just write like this way. They're just exactly the same thing. Here I'm just lazy, okay? And then while A is greater than 0. Sorry, I forgot to hit the column. It's extremely important. Then A minus, did I use minus or plus? Minus equal to 1, minus equal to 1. And then B plus equal to 1. Again, what's the meaning? This means A equals to A minus 1. B equals to B plus 1. So this means what? And then print AB. This means what? This means in each step, I will, do A equal to A minus 1 and B equal to B plus 1, and then print AB. And then every time I'm just going to see, is A greater than 0? Is A greater than equal to 0? And hence you will see it will be 3, kind of 2, it will be 2, 1. Why? Because in the first time of the running, it is A minus 1, which is 2. B plus 1 is 0 plus 1 is 1. Okay, so the first result is A is 2, B is 1. Okay, now I will go back to the statement again. Is A greater than 0? Yes, my A is 2, so it's still greater than 0. So do the same things again, do the same actions again. A equal to A minus 1, so I get A equal to 1, B equal to B plus 1, hence my B equal to 1 plus 1 is 2. Okay, print AB, which is this 1, 2. Okay, the third time is A greater than 0? Then yes, because my A is 1, right? So it's going to be A equal to A minus 1, and hence I get a 0 here. B equal to B plus 1, and here I get a 2 plus 1 equal to 3, and that's 3. And then print AB, okay, print 0, 3. Okay, now again, is A greater than 0? No, it's not. Why? Because A equal to 0. It's not strictly greater than 0, and hence stops. Stops means the whole while block, which is let me have a block here. The whole while block is done. So that's why it stops at 0, 3. Any questions here about the while loop? So this is a very simple example of the while loop. You need to understand why it stops here, because here my A equals to B, A equals to 0 and my B equals to 3, and I substitute, I go back to the logical statement. Is A greater than 0? No, it's not. It's no, this statement is false. Why? Because A equal to 0, and hence I'm not going to do anything, and hence it stops. Get a point here? Okay, now let's have a look at the next example. In the next example, I have A equal to 3 and B equal to 0, and then while A greater than 0 again, I'm gonna say actually the same thing. The difference here, I believe, is I add an else. So I said I have else. Let's say print. Let's say A is 0. Let me use F print. Print A is 0, and B is B. And you can see the only so first of all, this part is exactly the same as here, and hence the output. But the difference is that here, when we end here, which is A equal to 0, B equal to 3, then I go back to the logical test. Is A greater than 0? No, it's wrong. And the Python sees that I do have an else statement here. So I'm going to execute the else, which is print A is 0 and B equal to B, which is 3 here. You see what I mean? And again, this else, I remember I wrote here, yeah, the else clause is optional. You don't have to have it. If, let's say like this way, if there's no else, then when I'm done, the while loop structure, the whole structure is done, then that's it. It's done. If I have the else statement, else clause here, then I will execute the else clause, which is to print this, okay? And this example, be careful, because this is something with infinite loop. Okay, I'd better still do it, but before that, I'm gonna save. Save with just Control S, save, or you can just, I actually don't know where it is. Oh, okay, here, save notebook, just Control S, save, okay. This is a very bad example. You should absolutely avoid this kind of loops. It's called the dead loop or infinite loop. It will let the server let Jupyter forever run. There's no end, and you will see computer usage will be very high. But first of all, before I code it, let's see what happens here. So still the same thing, a equal to 3, b equal to 0, while a is greater than 0. The change is I make the from minus equal to b plus equal, see it? A equal to a plus 1, b equal to b plus 1, print ab, continue. And did you see that because my initial a is already 3, and you'll forever run it because a is forever bigger than 0 because a will be 3, 4, 5, 6, 7, blah, 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 forever. And you can see this loop will never end unless I manually stop it. And it's very dangerous. Why? Because it will just infinitely occupy your RAM, your computer memory, and infinity. You may say, "Hey, what's up?" I mean, it's I just stop it down. I just stop it. Easy, right? The problem is that, of course, here's a very baby example. In the real project, you could have many tens of thousands of codes, and then if you stop just one part here, all the previous results will be gone. It will waste huge amounts of time, and especially if you use GitHub or those kind of things, you have a team to code together. Oh my goodness, this your code could kill other people's work. So be very careful of those kind of infinite loop. Okay, so now let me sacrifice my life to run it, and it will waste some time, but I believe it's worth it because I do want to show you a very bad example here. Okay, let's come here. So I just copy paste everything, but change the minus. I will change the minus to be plus. Okay, and then I will run it. What you're gonna see that it will run forever, and then I will click this. But this means to interrupt the kernel. However, it may fail. The worst case, I will press because I'm using Windows. I will press F5 to brutally force this page to refresh. Okay, so I will just now let me click this one to run it, and then we'll see if forever stop. Okay, it stops because I remember when I was preparing this lecture, I click it, it doesn't care. It just ignore me. Then I have to brutally press F5 to refresh the whole page, let the browser to reload the server. You can play this when you are doing the exercise, but make sure before to just save it, okay? And you can see it's just so fast. It printed so many. You see, so many numbers. Where it is. Okay. So to save my life, I will just delete. I will go to command mode and I press D twice D to remove this cell. But this is just an example of infinite loop or dead loop. Avoid it. Okay. So I'm gonna press DD, delete it. Okay. I believe there's an exercise. Oh no. Before the exercise, this is something about break and continue. They are very important in the loop. Not only in the while loop. Later, we will introduce the for loop. It will be the same. So break means terminate the entire loop. So for example, if I have here, I'd better just really code it. So similar thing. Let's say a equal to 1, while a less than or equal to yes equal to 10. I'm gonna have print a. I remember 3. If be careful. If here I have both while and if structures. If a equals to 3, then I'm gonna have break, and then be careful about the indent. Did you see that by default, Jupyter Notebook is here because it thinks that I'm gonna still be in the if block, but the truth is not. I want to go to the while block, a plus equal to 1. So what's gonna happen here if I execute it? So while a is less than or equal to 10, I'm going to do it, right? First of all, I'm going to print a. The initial a is 1. Okay, a is 1. It says this is the for if loop here, if block here. If a equals to 3, break. Remember, break means what? Means terminate the whole loop. here the loop is a while loop, right? The whole while loop. In other words, as long as a equal to 3, it's gone. I'm not gonna do from the thing after it, which is a plus equal to 1, which is a equal to a plus 1. So first of all, when in the beginning a equal to 1, so print 1, I will print 1. Then is a equal to 3? No, a is not equal to 3. So I will execute a plus equal to 1. So now a equals to 2. Is 2 less than or equal to 10? Yes, 2 is less than or equal to 10. So I will continue to break the while loop. So print a, which is 2. Okay. Is a equal to 3? No, a is not equal to 3. So continue. I will continue the loop, which is a plus equal to 1, so a equal to 3. Again, a is less than or equal to 10, which is true. So print a 3. Here's the thing. If a equals to 3, break. Now my a is indeed 3. I will break. That means I will quit the whole loop. You see what I mean? And hence, I won't continue. So what you're gonna see is only 1, 2, 3. I can simply just print it. Let me just first of all erase everything, and I can just execute it. 1, 2, 3. Why it's not a 1 to 10? Let's say suppose I don't have this. It should be 1 to 10. See it? 1 to 10. But once I add it, it's gonna be 1, 2, 3. Why? Because I have a break here. Again, break means quit the whole loop. And hence it's going to be only 1, 2, 3. Okay. So here are some examples here. Here are some explanations. If you are not clear, you can just read the explanations here. And then let's see the next example, which is continue. So continue is different from break. That continue is to stop the current iteration, while break is to terminate or stop the whole loop. You see what I mean? So let's change the code from break to continue. See what's gonna happen. Okay, again, when a equal to 1 and 2, nothing happens. I'm not gonna trigger this if block. Okay, now suppose a equal to 3. Now I have if a equals to 3, continue. That means I'm not gonna do anything after continue. I will just simply just quit the thing here. I will wait a minute. Let me see here. Wait a minute. I think my code there's something different here. Let me see. Okay. Sorry about this. Yes, I know why. I know why I cannot write it. Sorry. Question: what if I write it this way? What's gonna happen? It will forever print 3. You see the point? It's actually an exercise here. It will forever print 3. Why? Because it will be something. Let me first skip it. Let me just let me use this example to explain. Continue first to make it more clear. So I will have to save my life. I'd better just have 4, I believe, and then a plus equal to 1, and then if a equal to 3, continue. Yeah, I need to move this a plus equal to 1, forward to this line. So now it's 1, and then 1 is less than or equal to 3, and then let me see. I will print. Let me. I'd better print here. Yes, I will print here. Pay attention to the indent. I print here. That means this print is associated with the while. It's in the while block. It's not in the if block. Be careful. Okay. So now I have 1, and then 1 plus 1 equal to 2, and then is 2 equal to 3? No, it's not. So print 2. Again, 2 is less than or equal to 4. It's true. So now 2 plus 1 is 3. Now is a equal to 3? Yes, it is. And it's continue. In other words, I will not do anything after it in this iteration. So I will skip printing a. In other words, a equal to 3 will not be printed. Okay, now my a equal to 3 is a less than or equal to 4. Yes, correct. So a plus equal to 1. So now my a equal to 4. Print a. So it's a 4. And then one more time, a is a less than or equal to 4. Correct. Okay, so now a plus equal to 1 means 5. So I will print 5 because 5 is not equal to 3. So I won't execute the if block. So then I will print 5. Again, go back. Is 5 less than or equal to 4? It's not. So I will stop the whole loop. It's finished. In other words, the result should be only 2, 4, 5. while this 3 will not be printed. 2, 4, 5. See it? Again, continue means what? Continue means stop the current iteration. Directly go to the while statement again. In this specific example, a equals to 3. And then I'm gonna skip any actions after it. I will directly go to the logical statement to see is a less than or equal to 4. Here my a is 3. 3 is less than or equal to 4, which is true. So 3 plus 1 is 4. And now I will print 4. That's why number 3 is skipped here, okay? Okay, now let's have a look at this exercise. I believe just now I've already mentioned here. So if I write it this way, which is just right here, remember this example, I'm gonna write replace break with continue. What's gonna happen? So first of all, a equal to 1, print a is 1. Okay, a plus 1 is 2. Okay, and then until a equal to 3, you're going to see if a equal to 3, continue. Be careful, when a equal to 3, because I have continued, I'm not going to execute this a plus equal to 1. Okay, so my a is going to be 3 again. Is 3 less than or equal to 4? Correct. So print 3. Again, if a equal to 3. Yes, a equal to 3. Continue again. Go back to 3 less than or equal to 4, correct, print 3, print 3. You will do this forever. And I can show it, but it's really it's really not a good code. Let me just I'm gonna do what? I'm gonna move this one here, right? I'm gonna move this one here, and then move this one here. And what you're gonna see is a 1, 2, and then forever 3, 3. Again, I'd better save it because I know it's gonna be a dead loop. Okay, I run it and then stop, 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 stop. Okay, okay, it dies here. You can see it ignores me, sorry. Then I have no choice but to refresh it. I have to refresh, reload the whole page. And so you can see this is harm of a dead loop. It's very bad. And then we'll have to wait to let the page to reload. This is a very baby example. I mean, it's not a really big deal. But again, if you have tens of thousands of codes here, it's gonna kill your life. It's really gonna kill you. So okay, where's the examples here? Again, I'm to press the Shift L to show the numbers. Okay, so this is a dead loop. I'm not gonna do it again because that's very bad. And if I remember correctly, this is also a dead loop. So let's have a look at it. Why is that? So a equal to 0, a is less than or equal to 4. If a, so what I do is I move this if structure up. Move this structure here. If a equal to 3, continue. A plus equal to 1, print a. What's gonna happen? So here's gonna be even more interested. So when a equal to 1, it's going to be a plus 1, which is, so I'm going to print 2 first. And then it's 2, then a plus 1 equal to 3. I'm going to be 3 first. Then if a equal to 3, continue. You see what I mean? It will just go back to 3, 3 less than or equal to 4. And it's a is still 3, 3 equal to 3, continue, continue, continue. So what's going to happen is that it's going to just print 2 and a 3. And then it won't print anything, but it will be a dead loop just forever. I I can do it, but again, I'm afraid I have to refresh. Okay, so if like this case, first of all, you will see one and two. Yeah, you will print 1, 2, and then looks like nothing, right? The truth is that the kernel is still running. It's still running. Why? Because it's just a equal to 3, while a equal to 4, equal to 3, 4, 3, 4. It's forever. You have to stop it. But you know, it's just doesn't print anything. Why? Because it's just stuck here. Continue, a is 3, 3 less than 4. The while loop is never done. So that's the issue. Okay, be careful of this as well. In general, just when you are writing a code, absolutely avoid those kind of dead loop. Be careful. For beginners, you may say, how do I know before executing, the code? How do I know it's a dead loop or not? While it is something. It's to be honest, really experience based. You write more and more, you can easily detect something's wrong. Or if you see those kind of, I just remove it. If like infinitive this kind of printing, then it's probably a dead loop. Okay, so this is everything about the while loop. The next one is, sorry, I should have another example here. Guess number game. So in this game, we will let the user guess a number, which is the secret number. This secret number will be between 0 and 9. And then I will ask the user to guess a number have under a maximum attempt number of attempts of 3 times. So in this 3 times, if the user successfully guesses the number, I will print you nail it. If the user failed all the three attempts, then you will print game over. So let's see how to write this code, use a while loop. First of all, why do we need to use a while loop? The reason is because I will have, just repeat because I will have the user to guess for 3 times. Say, suppose your secret number is 8. Let's say, suppose my first time of guess is 5. And then it's going to be wrong. So you will do the same thing again. You will say, hey, no, 5 is wrong. Guess it. Now you have, let's say, 2 times of 2 chances. Okay, now let's say I guess it should be 6. Oh, 6 is not 8. It's again wrong. Okay, now you have 1 time left, 1 chance left. If let's say I said, oh, it's 8, then yes, you nailed it. You are correct. Or if I make it wrong again, let's say I guess it's a 1. Okay, wrong. Then you're gonna say here, which is game over. You have used all the total, let's say 3 attempts. Okay. So let's see how they make it. So here we're gonna have the secret number equal to 8. Since we have not introduced the function, let's assume we fix this secret number to be 8. Okay, and then the maximum guess number equal to 3. Okay, now I will write loop, which is a while loop. But what is the logical statement in this while loop? You can see the key is I want to see how many times has the user guessed. This is the thing. So in the beginning here, I can write I equal to 1 to indicate this is the first attempt, the number of attempts. This is the first attempt that the user is gonna guess. So while I is less than or equal to the maximum guess number, what I'm gonna do, I'm gonna say the number guessed, let's say guess number equals to, let's say here will be an integer because as we mentioned, it will be an integer, an integer between 0 and 9. So we will say, let's say input, let's say guess a number, an integer between 0 and 9. And here I want to show the number of chances left. So I will have an f print here. I'll have an f input here, similar things, f print or f input. And I will say, how many chances left. Okay, but how to express the how many chances? Recall that I'm at the ith attempt of the guess, right? And my total number, my maximum guess number is this. So it's going to be maximum guess minus I plus 1. Why plus 1? Say, for example, now I'm currently at my first attempt. So it should be 3 minus 1 plus 1. I still have 3 chances left, right? Similar things. If I'm in my third chance, then it's going to be 3 minus, wait a minute, it will be maximum guess 3 minus I equal to 3 plus 1, which is 1 chance, the last chance left. Okay, so this is the thing. And then after I get this number, I'm gonna see whether the guess number equals to the secret number. So if guess number equals to the secret number, then you're gonna do what? You're gonna print. You nail it, right? You nail it. And then what shall we do? We're gonna break. Why? Because the user has already successfully guessed it. You don't have to, for the second attempt, the third attempt, you don't have to do it. It's already done. The user already, has already won the game. That's it. But what if the guess is wrong? What would you do? You will just make I plus 1. Why? Because this means, for example, if I equal to 1 here, the first attempt is wrong. So now my I equal to 2. I'm gonna have the user start the second attempt of the guess. And then you're going to go back to this while loop. You see it? So you're going to, again, let's say I equal to 1, 1 plus 1 is 2. Now, is 2 less than or equal to the maximum guess number, which is 3? Yes. Okay, now it will be the same thing. Okay, guess the number, but the difference that since your I currently equals to 2, here, how many attempts would you have? 3 minus 2 plus 1 equal to 2. So you will have 2 chances left. And finally, 3 times left. And then what if, let's say, the next 1 time left, 1 chance left. What if the user fails all the 3 times, all the maximum number of guess chances? Then this one will be broken. This logic will be false. And hence, I need to write an else here. Be careful of the indentation here. The else gonna be with together with the while. So my indent will be here. Else means you're gonna be game over. Print game over. You have used up all the how many attempts. So what is the number? It's the maximum guess, right? Okay, here we go. So we can just guess. So currently we know it's 8. Suppose I don't know the side. Guess 6. Oh, wrong. Oh, wait a minute. Why didn't it print? Wait a minute. Something's wrong. I should have print it. Sorry, I should make it here. Print. Wrong guess. Okay. Now let me rerun it. Cell not exit due to pending. Okay, I can just stop it. Let's say 6. Wrong guess. Another guess. And you can see in the beginning, 3 chances left here, 2 chances left. Let's say 4. Wrong guess again. Suppose I still don't know. Suppose I guess 7. It's gonna be wrong. Wrong guess. And then game over. You have used all the 3 attempts. Okay, let's rerun it again. Suppose the first time is still wrong. The second time, I know I'm cheating, but suppose I guess it's 8. Okay, you nail it. See it? So this is how this game, is written. And later we will learn class and also learn. Class is structure. Learn class and also learn function. We will rewrite this game to make it to be a function based, so that you can put this maximum guess and the secret number all as parameters instead of cheat it like fix it in the beginning. Okay. So this is, I believe, everything I want to introduce for the while loop. Any questions? No? Okay. So the next thing will be the for loop. For loop is pretty similar to maximum loop, to while loop. The difference is here. For loop, typically I'm gonna say for what in something, so for element in sequence. This sequence, for example, can be a list or something. I mean, the thing you see the most is actually the list. You will see like this. The difference is that for the while, we typically need to, this logical statement, we need to put something like I is less than or equal to something. But here, for, I can just write in something, which will be actually easier. You will see it in the examples here. And also, do not forget first the column and also these indentations. Okay, let's see examples. I guess it's easier to explain in examples. Okay, so now I have for x in string cat. Print x. So what happens is that for element, so this cat is the so-called sequence here. You can make it to be a list. Later we'll have an example. The next example, I believe, will be a list. But this is, you can put in anything. And then print x. So the first letter is C, the second letter is A, the third letter is T, so CAT print. And immediately you might say, hey, why you say for X? Where is this X from? Actually, this is the name of the element. You can call it whatever. You can call it, let's say, A, B, C, D. And then don't forget you're going to change A, B, C, D as well. You see what I mean? This is just a variable name. You can call it whatever things. It's going to still be the same. Okay. Then the next example of for will be in the list. Here, cat is a string, element in string. Here, we're going to see element in list. So I'm going to have the list, let's say pets equal to cat, dog, and the fish. Okay, you can say, again, you can use A, B, C, D, whatever you want. For A, B, C, D in pets, this pets is a list. It's going to print each element, cats, dog, fish. It really doesn't matter. Or you can say in my slides, I believe I wrote element or I wrote path. It doesn't matter. As long as you remember what is that, it is that. It is. You can call it whatever name. Okay. So this is the for loop. And later you will see in practice, I would say, at least myself, I use the for loop much more than while loop because for loop is easier. I can just create a list or I use a range function or something. I can just say for something in something, which is way, way, way easier. I don't have to count, oh, the length of the how long it is. No, I don't care because I just use in. Okay. And then the next example is here. So I can use this to calculate the summation of all the elements here. So I have, for example, prices equal to, let's say, 2, 5, 10. And then I can have total cost equal to 0. This is my initiation, my initial value of the variable total cost. So I can say for price in prices, I'm gonna have total cost plus equal to price. And then you can say print the total price is what happened? Is total price. Total cost, sorry. Here we go. And this is doing nothing, just summation of 2 plus 5 plus 10. You see what I mean? That's it. And remember the very beginning example, which is which is what just the list, right? So for example, how to add a list, add something in the list. Remember, we use append, right? Okay, so I can write it this way. Let's say list 1000 equal to empty list, and then I'm gonna say for I in range 1000. Range 1000 means 0 to 99. Then I'm gonna say list 1000 dot append I. And then finally, let me make my life easier. Let me make 10 because 1000 is difficult for me to check. Let's say make 10 dot append I, and then I can just print list 10. Here we go. 0 to 9. You see what I mean? You don't have to like for each one to do manually. You can easily make it to be 10,000 or whatever number you like. You know, it's gonna be the same thing. And then what if I wanna, like what I mentioned in the beginning of loop, I want to add a one number. Sorry, where's the loop? I want to add a one to each element. Simple. Then you're gonna say list 10 I plus equal to 1. Plus equal to 1. So it will be 1 to 10. You make it again. I will. I need to delete this line. Sorry. Let me just write it in another cell because otherwise it will clear everything. So now I already have this is the list 10, right? So I'm gonna say in range 10, less 10 I equal plus 1. Then it will be from 1 to 10. See it? So each element added 1. So this is how we can use the loop, for loop or while loop to do those things. Let's continue the example here. I have finished this one, and then okay, here is the combination of the for loop and the if, and also with the break here. So I have the numbers here. Numbers equals to whatever number, 2 negative 1, 5, and then I'm gonna for, let's say for x in numbers. Again, you don't have to call it x. You can call x. You can call y. You can call number in numbers. It doesn't matter. If x is less than or equal to 0, break, and then print. Be careful. This print x is under the layer of for instead of if. Okay. Guess what's gonna happen? So it's gonna judge whether the number is negative. If it's less than or equal to 0. If it's less than or equal to 0, it will break. In other words, I will just ignore any number starting from this non-negative, non-positive number, right? And hence it will print only 2, 3, and 2. See why? Because once it detects this x equal to negative 1, it is x less than or equal to 0, break. Break means what? Break the whole loop. the whole for loop. And hence this -1, 5 won't be, considered. Nothing will be done. So what if I change this break to continue? It will just skip this -1. It will continue for the next element, which is 5. 5 less than or equal to 0, wrong. So it will still print 5. So the result will be 3, 2, and 5. 3, 2, 5. Here we go. Okay, so this is, I believe, these two examples to show the difference between break and break and continue again, but this time is in the for loop, not in the while loop. Okay, and here is something, something I personally call it a lazy man's loop. So it is a list comprehension syntax, which is just sometimes if you want to create something, just inside, you want to just write everything in the list structure itself. So it will be expression for item in sequence if condition. So for example, here I can create something to create something in range 10, which is from 0 to 9, if its module 2 is 1, meaning it's an odd number. So I can write it in this way. Let's say I have list, let's say odd 10 equals to I for I in range of 10 if I %2 or reminder 2 equals 1. Then I can print list odd 10 list. It should be 1, 3, 5, 7, 9. That's it. You can of course say, hey, I don't want to use this method. I just want to use the way we used here. Sure, but you're gonna write it in this way. You will write it to be list odd 10 equal to first create. Remember what we did here? Actually, they're the same. You will need to first create an empty list, and then you will for I in range of 10, and then you're gonna do what? If I reminder 2 equal to 1, then you're gonna data dot append I, and then print list of 10. Wait a minute. Not data. Sorry. I was looking at the list of 10. They're the same thing. However, you can clearly see this is a much more concise. And as a lazy man, I personally like this kind of things. For those kind of simple, constructions of the list, I typically use like this way. Okay, so this is the for loop, and the next one will be the nested loops. As we've seen before, for a list, we can have multi-dimensional list. Similar things here, we can have nested loops. So here I can have, for example, have two layers of 4 x in range 2, and then 4 x in range 3. Again, range 2 means 0, 1. Range 3 means 0, 1, 2. And then I can print, let's say, let me make a printf of x and y. So it will be, sorry, range ANGE. Why not for x? Okay, here we go. So this means what? This means, okay, first of all, I will do for x equal to 0, and then I will do the inner loop, which is for y equal to 0, 1, 2. So x equal to 0, y equal to 0, print. Again, now it's in the y is equal to 1, so x is still 0, 0, 1, and then y equal to 2, 0, 2. Now I've already done, you see what I mean? Because this one's range 3, let me write. Range 3 equals to this, a list of 0, 1, 2. Or I can actually just simply print range 3. You can see. Anyway, it doesn't show, but range 3 actually just shows you a list which is 0, 1, 2. So now my y has already, taken every element there as finished. Then I will go back for the for loop, for the x for loop. And hence here is range 2 equals to 0 and 1. And hence now my x equals to 1, and then I will do it y in range 3 again, y equals to 0, y equals to 1, y equals to 2, and hence this is the result. So this is more than one level of for loop. This is called the nested for loops. And similar things, I can use this to play play different matrix operations. So here I have a matrix with this one. And then first of all, I can get the row number, which is the length of the matrix itself. And then I can use the column number, use this one to get the length of the matrix. So it will be row number is 3, column number equal to 2. Now what I can do is for each element here, for I in row number, for j in column number, I will plus 5 to each element here to each element. In other words, this one will be 6, this 2 will be 7. So I know, sorry, this time to save my time, I'm not gonna run this code, write this code in the Jupyter notebook, but you can do it by yourself, and you will see this route. The meaning is basically to add 5 to each element. So that's the meaning. Okay, here let's do an exercise. The exercise is to, for a given number list, I want to write a code to find the smallest number in this list. Again, here the number list will be provided because we haven't discussed like a function or something, which is the next topic. Okay, so we'll just write the code here. The num list equal to, I just write whatever number next to, let's say 3, next to 3, 5, next to 10, 100, whatever number, it doesn't matter. And then how to get to the minimum number. Typically, I can just let the minimum number to be the first number, to be the 0th number, equal to num list 0. And then I will write a for loop for x in num list. What to do? So if this x is less than the current main number, then I'm gonna have the main number equal to x. So for example, my first number is 3, right? Okay, now 3 equal to 3, so I'm not gonna do this if. The next number, -3. Is -3 less than or equal to, or less than my current main number? My current main number is 3. It is. So my new main number is going to be -3. And then 5, -10, 100. Just a loop. And then finally, I'm going to just print. When I finish this loop, I'm going to print main number. And down. And easily, this is 10. Or if you want, you can even, let's say, put the index here, which is the main list dot index, and you're going to search for this main number. And it tells you the main number is -10 and the index is 3. And indeed, 0, 1, 2, 3. You can see this. But what if, let's say, I have two different, same number, both are main? It doesn't matter. Why? Because since both are main, so I can just simply take the first number, as the main number. And you can definitely later, if you want, you can just write a bit more to find all these numbers, which is actually super simple. Just in the for, right? Under say, remember the index, you have a start. You make the start number to the previous, index plus 1. So you can always, use this method to find all the number. Okay, I will leave it as an exercise after the class. I will finish one more exercise, and then we'll finish today's class. So this exercise is to remove all duplicate elements in the list and print the new list. I'd better here above add something here to the exercise. What's the number? 27. Okay, now here it will be exercise 2.8. Okay, so I need to first have a list and then remove all the duplicate list, duplicate numbers in this list and print the new list. Okay, so first of all, let me just create a list, whatever, let's say 2, 3, 4, 4, 5, 4, 5, 3, 1, 1, for example, whatever list. So now I want to create an empty list called a unique list. So this unique list will save all the unique elements here. My idea is this: I will write a for, which is for all x in or element in the list. Let me rename the better because later I will use something called list 222. Our for x in list 222. So I will compare. I will see whether each element is in this unique list. If it is in, then I'm not going to do anything. I will pass it. and then I will use the for to go to the next element. If it's not in, then we'll add this one, use append, add this one to the unique list. So I will have if X not in list 222, where list 222, then I will do what? Unique dot append this X. And then finally just print unique, then done. And I will omit 4x, sorry. Not for X in the list, for X in unique, because I want to find for each element, I want to, let me find another file. I want to find whether it's already included in this unique, okay? And here we go. For X, no. For X in list 222, if X is not in unique, then here we go. And indeed, you can see the result is it removes all duplicated. Say 4, I have 4, I have 2 4s. But this only shows 1 4. And also I have how many 2s? I have several 2s, right? It shows only 1 2 and similar things for 1 and 5. See? So this is the idea, that the basic idea, again, algorithm is I create another unique and I compare for each element in list 222. If it's already included, then I'm not going to do anything. If it's not, then I will append. And finally, I will get a unique list. Okay, so here's everything. So in the next class, we will introduce function and class structure. That's everything about today's class. And again, the lecture will be uploaded to the YouTube in this playlist. You can just click it. And also for the Google Drive, I've already changed changed the share option here so that anyone with the link can see it. So I believe now everyone should be able to see everything. That's everything for today's class. Thank you very much, and have a good night. Bye bye.